Guys and girls, video here on powers and indices, which are actually the same thing, but still people call them different things. So anytime you see powers or the word indices, just think the little numbers. And by that I mean things like 2 squared, that's the power, or that is an index. Right? So more than one is called indices. So the little numbers are what we're talking about here. So what does the little 2 mean? Well, it means 2 2's multiplied together. And if you had it on a 5, it would mean 2 5's multiplied together. And so on and so forth. What does this mean? Well, it means that there's 3 7's multiplied together. And what does that mean? It means that there's 5 1's multiplied together. Right, that's all it is. So the key ones are the square numbers and the cube numbers, which hopefully we should know. But you need to know up to 15 squared, so the square numbers. So you can either memorize them or you need to know how to work them out. So you've got 1 times 1, 2 times 2, 3 times 3, all the way down to 15 times 15. Now I'm not going to write them all out, that's your job. But you need to go 6, you need to go all the way down to 15 times 15. I will give you those ones that I've written on the screen. And I'm going to clear that up. So 1 times 1, I hope nobody said 2. 1. One lot of 1 is 1. 2 2's are 4. 3 3's are 9. I'm sure some of you just said 6 there. It's 9. Then 16, 25, 36. And then 15 times 15. You probably haven't memorized that, so we need to work it out. So 15 times 15. I'm going to do quite a few methods. So you've got columns. So 5 times 5 is 25. 5 times 1 is 5, 6, 7. To fill the gap, 1 times 5 is 5. 1 times 1 is 1. Add them up and you get that. So if you're happy with using columns, use columns. If you want to use Napier's bones, use Napier's bones. It really does not matter which method you use as long as you have a method. So 1 times 1 is no tens 1 unit. 1 times 5 is no tens 5 units. 5 units. And 25 times 5 is 25, so that's 2 tens and 5 ones. And you add up your diagonals, so this diagonal comes to 5, then 5, 6, 7, 12. Carry the 1 up onto this diagonal. So 1, 2, oh, I forgot to add the carried one. 2. So the answer is 2, 2, 5 again. You can do grid method, which is very similar to Napier's bones, but it's got a few more zeros in it. So 10 times 10 is 100. 10 times 5 is 50. 10 times 5 is 50. 5 times 5 is 25. Add them up, you get 2, 2, 5 again. You can chunk. So 15 times 15, you can split into 10 times 15 and 5 times 15, if you like. So that would be 150, and this is 75, and add them together as 225. There's a whole host of ways. You just need to have a method that does not involve a calculator. Okay, these can, and more than often do, come up on non-calculator papers, so you do need a method. So if I asked you what is the 12th square number, that would be asking you what 12 times 12 is. Okay. Moving on to the cube numbers. Now you don't need to know as many of these. The only ones you need to know are 1 cubed. Actually, let me write it as in power first. So 1 cubed, 2 cubed, 3 cubed, 4 cubed. That's dodgy. 5, 6, oh Lord. 5 cubed, 6 cubed, and 10 cubed. They're the only ones you need to know. So what does it mean? What does 1 cubed mean? It means 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, and so on and so forth. So what's 1 times 1 times 1? Don't say 3. Think about it. It's 1. 2 times 2 times 2? Well, we know that 2 times 2 is 4. Times that by another 2 is an 8. 3 times 3 is 9. Times that by 3 is 27. And then you need to work the others out. All right. So we know 4 times 4 is 16. I need to do 16 times 4. Okay, so on and so on and so on. Okay, but they're the only ones you need to know. Right, what about if we had something like this? And I was asked to put it as an index, write it in index form, they call it. Something like that. What's this? And then what's this? What about this one? Well, it's just a case of write the number that's repeating and then count how many there are. So here there's 1, 2, 3, 4, 5, 6, so it's 7 to the power of 6. 1, 2, 3, 4, so 3 to the power of 4. 1, 2, 3, minus 2 to the power of 3. All right, I haven't got to work it out because it's asking for index form. So I haven't got to work out 7 times 7 times 7, blah, 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 blah. Don't need to, no point. You'll be making your life a heck of a lot harder if you don't read the question. If it says index form, do not write out an answer or a number answer without the power on. That's really all there is to it. If you're writing in index form, it's counting how many of the numbers repeat. Otherwise, you've got to know your cube numbers or your square numbers. They can ask you to work out things like 5 to the 4. Of course they can. So this could come up on a non-calculator. If they ask you how to do that, personally, I know that 5 times 5 is 25. So 5 times 5 is 25, so I've got to do 25 times 25. And then you use your method. So Napier's bones, why not pick that one for now? Whatever method it is you do, these really should be done with a ruler. But 4, 10, 10, 25, so 5, 2, 6, 6, 2, 5. All right. It doesn't matter how you do it, just know that you've got to be able to work these things out. Anywho, that's enough on that. I will see you next time. Bye.